Hi, everyone. Thanks so much for joining us. Happy Thursday. Today on our webinar, we are going to cover a relatively new service, Amazon Forecast. It is a time series forecasting service that is based on the same technology that we use at Amazon.com. My name is Sue Ewig, and I'm the AWS Global Partner Marketing Manager for AI and Machine Learning. I essentially schedule these calls, so appreciate you joining today and hope that you saw the list of the next couple calls in this series that we have coming up. I want you to feel free to ask any and all questions you have on this call. The lines are muted, but we do have a question answer pane in the right navigation of the GoToWebinar tool. So just pop those questions in there. You can make those visible to just our presenters, or you can make them visible to everybody. It doesn't matter necessarily. If we don't get through all the questions, we'll summarize both the questions and the answers in an email after this call. So don't fret. I'd love to introduce our presenters for today. Our main presenter is Kris Skrinak. Kris is a partner solutions architect and the global machine learning segment lead for the AWS Partner Network. Kris started his career as a quantitative strategist at Goldman Sachs, where he developed predictive maintenance apps. Also as an AI engineer at AT&T, and prior to AWS, he was a computer vision architect at GoPro. As the technical lead for horizontal support of AI/ML, he is the first line of support for you guys, our AWS partners who are looking to develop or expand your use of those technologies across all markets, including finance, healthcare, public services, telecom, e-commerce. Also on the call today, we have Chaitanya Hazare, who is also a partner solutions architect with AWS, specializing in AI and machine learning. Chaitanya presented on our call last week, and he's here today to help answer questions as they come up on the call. So that is the introduction of our prestigious presenters, and I'm going to pass this over to Kris to get things started.
Thank you so much, Sue. I am Kris Skrinak, and speaking to you from lovely Melbourne, Australia today, which I'm very happy to be in at the moment. So good morning to everyone on the West Coast, good afternoon on the East, and if, God forbid, you're up at this hour in Asia, I'm honored, so thank you. So we're going to take a look at Amazon Forecast today. This product is not in release yet, so it was announced. It is a newly announced product, but unless you're signed up for the preview, and I encourage you to do that right now, unless you're signed up for the preview, you won't be able to sort of follow along. If you've taken one of my workshops, you know I love getting hands-on. You know, the story is that AI is in PowerPoint and machine learning is in code, so I love having hands-on in code. But unless you have signed up and have been whitelisted for this particular product, then I regret you're just going to be able to look at these slides. So do that right now. Why not? While this webinar is going on, go to the AWS console. You may need to set your region to either Oregon or West Virginia, so be conscious of that. I'm not 100% sure whether that's a requirement, but you may need to do that. Click on Forecast or search for it and then click on Forecast. And if you're not signed up, you will get an announcement on the page to click and sign up for the preview. All right, so let's start off with some of the basics here. First of all, the forecast is really what most people think of when they think of prediction. You know, can you take a look at my inventory? Can you take a look at some of the aspects of my business where I have to do capacity planning? And can you tell me what it's going to look like in the future so that I can plan accordingly? That might be, you know, product demand. How many people do I need working with me? What are the financial metrics going to look like? So accurate time series forecasting is absolutely a fundamental requirement in almost every business. And what we're doing with forecast is we're taking the most powerful time series forecasting tools that exist in the world at the current state of the art and really making it easy to use. So as Sue mentioned in the introduction, this is the exact same technology that we're using at Amazon, where we obviously have enormous capacity issues. We have more than 2 million vendors selling products on Amazon.com, the retail site, and they are providing more than 2 billion individual products. And what's really wonderful is that with this particular service, you need no prior machine learning experience, no prior coding experience is required. So Amazon Forecast is designed to be a RESTful, SaaS-based, and even just graphic user interface-based product. Like all the other higher level services at AWS, if you understand REST, if you know how to call an API, you're able to use any of these services and integrate them into your daily workflow. I do want to take a quick look at the machine learning stack, because just to sort of orient ourselves on where Amazon sits, at this very, very top level, we have AI services, and those are all the services that you're familiar with, the Lex and Poly, for example, where you can take advantage of deep learning and really sophisticated solutions, more than just machine learning features, to do vision, natural language processing, and now forecasting, and some of our other products that are in beta, public release, public beta right now include Personalize and Text Track. So this is sort of the icing on the cake. It's where we've taken the best of what's available both in open source and with the extensive more than 20 years of experience that we have at Amazon doing machine learning, and present them to you in packages that are highly familiar. In the middle area, we have what we call our ML services. That is principally SageMaker. That's where we can do the essential aspects of labeling data for supervised learning, using Jupyter notebooks to train custom algorithms, and importantly, being able to deploy at scale with the kind of elasticity that you expect from the entire AWS infrastructure. On the bottom level, we have, the most powerful GPU instances on the market, and we have the frameworks including the TensorFlow, PyTorch, MXNet, that are built into something we call the deep learning machine image, the deep learning AMI, that make it possible for you to stand up a system and get to work right away in a coordinated manner with the most powerful machine learning frameworks that are available. And here they are, they're sort of the stars of the show. On the top level, you see the vision, speech, language services, etc., with recognition image, Lex and Poly, transcribe, and what we're going to get to today, which is actually our Amazon forecast. Before we do, I've introduced this flow diagram into all my workshops now, and this is the way that I'm looking at the proper process now for approaching any machine learning problem. And I wouldn't have given this presentation and this particular slide even 6 months ago, but this is a very fast moving field. And I think this process, this approach is really important. In machine learning, it's more important than ever that you have a really well-defined business problem before you get started. Now, of course, whenever you're doing any kind of software development, you need a good functional spec. You need to know why and what you're writing with your software. But in machine learning, it's especially important because machine learning is an experimental process, and it's really easy to get derailed because of that experimental process. It's also really important to understand who are the stakeholders and be able to communicate with them, both with text, with a weekly cadence of charts that might come from a platform like Tableau, or within your Jupyter notebooks with Matplotlib, PyPlot, to really understand what is the business problem, who are the stakeholders, be able to communicate with them so that you stay on track while you're solving that particular problem. Once you have that problem well defined, it's important to frame it as a machine learning problem. So what that means specifically is that when you're solving this business problem, it's not a binary situation. I like to make the joke, nobody ever got the message that they have a 98% chance that they have new mail, right? But everything in machine learning is going to come in some kind of predictive probability. So making sure that you're predicting one of the essential three things, you're predicting either a number, a class, or you're discovering a class through an unsupervised technique, that you're able to frame that problem as a predictive probability is really important. So, you know, I often say there's only three things you can do in machine learning. You could predict a number, that's regression, predict a class, that's classification, or discover a class within your data, which is typically just called clustering. If you're able to do that, then you've got a machine learning problem. But you know, 4 out of 5 problems, once really carefully considered, are probably solved through a heuristic method. And I guess the advice and guidance I give here is, if it's not a machine learning problem, don't make it one, right? There's a lot we could do with deep learning now that really kind of magically transforms a lot of problems into deep learning solutions, but you may find yourself wasting a lot of time and sort of chasing your tail. All right, so you've got this 1 out of 5 situation where you really have a machine learning problem. So what's the first approach? Well, the first approach should take a look to see if somebody's already solved that problem. We have now built within SageMaker the SageMaker Marketplace. The SageMaker Marketplace has more than 200 solutions from some of the most sophisticated machine learning ISVs that are out there, and companies that are beginning to sell their algorithms and trained models right in SageMaker. You can also just search for Amazon Machine Learning Marketplace, and you can go through our Marketplace portal and go right to those solutions. This is a fast-growing marketplace, and because solving machine learning problems can take weeks and months, it's embarrassing, if nothing else, to discover after a period of time that someone else has already solved your problem. But you'll also find, say, if you're consulting, a consulting partner, that, you know, it could be really, really costly and something you might have to justify when you see that these problems are already solved. There's more than 200 solutions there today, and it's very fastly growing, very quickly growing. Next, take a look at the Amazon machine learning services, including forecasts like we're looking at today. And the beauty of this approach is that no training data is required. Now, we do sell algorithms in addition to trained models, so training data might be required for the algorithms, but 80 to 90% of the time, effort, and money in machine learning development is working with the data, finding the data, massaging the data, doing feature engineering, etc. So when you have a trained model and you have all you need to put that model into production, you know, you've really saved yourself a lot of time and money. So if you don't happen to have a solution there, then training data will be required. So that is the next step. Make sure that you have training data sufficient to solve your problem. Then you'll want to take a look at the SageMaker built-in algorithms. There's more than a dozen extremely robust algorithms built into SageMaker. And if you have the data, you've cleaned it up, etc., you can do your regression, clustering, classification, object identification, natural language processing, including doing the sorts of things we do with LDA and natural neural topic modeling. So all of that is already built into SageMaker. And when you use a SageMaker built-in algorithm, as opposed to writing something from scratch, you get a number of advantages regarding scale and optimization. So when you're using, for example, the linear learner for a logistic or linear regression within SageMaker, you can automatically scale. What that means is, let's say you have petabytes of data or terabytes of data, and you start with a small sample set, and you're beginning to train, and then you say, okay, well, this is really, really big. How am I going to grow out of that single GPU? Even though a P3 might have a single GPU with 64 gig in it, let's say, you know, you have this petabytes of data. What are you going to do? Using the built-in algorithms, you can grow out of that individual GPU in your training phase into the entire 8 that might be on a single machine, and grow out of the machine itself into a cluster for training. And there's really no limit to the number of machines that you can launch to do that training. And of course, like every other service at AWS, you're billed by the second. So you're create this, begin to launch this algorithm either from the GUI or maybe command line or even from your own laptop using SageMaker Local, and you launch that training in the cloud at scale, and a job that 2 or 3 years ago might have taken days or weeks will be done in hours or minutes. And of course, like every other service at AWS, it's billed by the second. So it's really highly cost optimizing. Also, we do automated hyperparameter optimization for you with these built-in algorithms. So your model will be compared against several other models as it's being created for you, as long as you include a validation data set. And if for any reason you're not happy with the results of our automated hyperparameter optimization, we've exposed the entire hyperparameter optimization API within SageMaker. This is a really powerful features. Last but not least, you may have to train something from scratch, create your own algorithm. That certainly does happen. But the reason I go through, this new foil here is, frankly, that's the last stop on this train in this day and age. And I think it's the way it's going to be from here on. You might see whenever we do presentations about SageMaker how wonderful it is, and frankly, it is wonderful. I use it every day. We tend to start there, but just because we want to show how dynamic it is. But the process now should start in the marketplace. Take a look at our managed services, take a look at the built-in algorithms, and then finally, if you have to, write something from scratch. So let's get started now with Amazon Forecast itself, our time series forecasting service. So what is forecasting? Well, forecasting is obviously always going to be used to look into the future, to make predictions in the future about some data about which we have time series information. Now, time series information is really common in a lot of situations. Certainly, if you have a transaction log, at a minimum, your sales, that transaction log is going to be broken into how many sales of what products did you have for each day. So clearly, that's sort of the first step in understanding prediction. It would be nice to take a look at all of your product line and have some idea how much inventory do I need to keep on hand, and what am I going to need to make sure that I can satisfy that demand. So if you take a look at this chart here, sort of on that center tick on the time chart, we're saying, okay, there's some seasonality, there's some differences day to day. Let's just use the inventory use case for this particular example. But in the future, I'm not sure if I need to stay at the current levels, whether I need to amp up my inventory so that as demand grows, I can meet demand, or demand's going to go way down. I don't want to waste my money spending on inventory if I don't need that. So this is sort of the basics of forecasting and prediction. Some of the other use cases that I've seen besides retail and inventory planning for, say, supply chain is EC2 capacity. You may simply need to understand, okay, here's our transaction logs. Say we're using a product like Splunk or Kibana. We're taking a look at our logs. And we know in the future, the sales holiday, the holidays coming back up, and sales are different than they are right now. So how do we plan for that? If you have any kind of workforce requirements, whether you're in construction or oil and gas, in some other field where labor is absolutely critical to plan for, you can take a look at the statistics that you have, the time-based statistics, and plan for that. Web traffic is a really common use case. If you have a website, and even if you're not selling anything on that website, but you need to keep up with demand, you can use your web logs to estimate for future web traffic. Metrics, all kinds of financial metrics such as revenue and cash flow. How much money do I need to borrow, perhaps? Or how much can I pay down my existing loans? And really almost any kind of data that can come in with a timestamp can now easily be read into forecast, where we can automatically set up a predictive endpoint for that purpose. So So what's different about forecast than, say, traditional methods? Well, with the advent of deep learning and a number of algorithms, which I'm going to review in a moment, there's a few problems that, let's not say are completely solved, but they're really minimized. One is that data tends to be seasonal. As I mentioned before, the holiday season has a lot more activity for retail than other times of the year. Sometimes it's just something like one of your competitors' stores is shut down, or there could be intermittent holidays or sales events that regularly happen within your business. When you're using deep learning techniques, we tend to find this latent information within the data. What I mean by latent is it's not obvious to the eye when you're looking at charts or trying to predict what's going to happen next, that there's a seasonality to what's happening in my data. But deep learning techniques are beginning to uncover all of this information, and it's apparent especially when we're using algorithms like Deep AR, which is built into SageMaker. Also, there's a correlation between data that is now much more easily revealed when using deep learning techniques. So if you're familiar with ARIMA, which has sort of been the superstar forecasting over the past few years, it's difficult to take a model like ARIMA and put correlating factors along with the principal factor that you're interested in to make predictions in the future. So what does that mean? So let's say that you sell sneakers, right? But as winter comes around, boots begin to pick up in sales, and there's a relationship between sneakers and boot sales that you may have an intuition about, but with deep learning techniques, the algorithms, deep learning algorithms, can begin to find relationships and do predictions that are simply not apparent to the naked eye. Finally, if you're going to introduce new products and you have no pre-existing data, deep learning techniques can make predictions that are very, very accurate now about what can we expect when you introduce this product. How can we use some of the data that we have about other products to look forward and give us a good heads up so that we can plan accordingly. So that's why we introduced Amazon Forecast. It draws on all of our experience here at AWS, and the package includes, importantly, a suite of 8 algorithms with 5 deep learning techniques and 3 statistical methods. So, we haven't thrown out the good with the new. I'm going to take a walk through each of those in a moment. But what we have seen in our results, both with the work that we do for ourselves at Amazon and for our private beta customers, is that we're seeing accuracy increase up to 50% for time series data, especially when there is a lot of data involved with that time series. So here's what the process looks like, sort of highly simplified. First of all machine learning starts with data. In machine learning, data writes code. That is absolutely the fundamental principle. So when you have historical data, such as supply chain, inventory, etc., and you're able to get some related data, and that might be weather, special programs or campaigns that you ran, and importantly, product details, you can load that into Amazon Forecast and get a customized forecasting API. If we dig into that just one layer lower, here is the actual process along the way. So first of all, you load the data, and I'm going to define a few concepts and key terms to help to understand how we do that with Forecast itself. So we load that data, we create data set groups and the data sets within that group. Amazon Forecast will inspect that data automatically for you and do feature engineering. So we'll go through the data, take a look at which of your features are influential in making these predictions. We might combine some of that data for you and eliminate others that are computationally expensive and sort of irrelevant. We'll do algorithm selection for you if you choose, or you may choose manually to pick one of our algorithms. And then we do the kind of stuff we do with our SageMaker built-in algorithms. We'll do hyperparameter optimization, we'll select the correct parameters, we'll train the model, optimize the model, and then finally we'll host the model so that you can run data, new data, against that model on demand. Let's see, I guess I kind of covered this, but you know, there's a lot of uses for this. Maybe this is out of place here. I won't repeat myself here. But I will say that in our private beta, we've had 2 customers that have shared their experience. This is available online, CJ Logistics and Mercado Libre. So it's certainly worth taking a look at their experiences and see if that's something that you can compare to your own. All right, let's get into this process. So the first step in the process always is to collect and prepare your data. Now, data preparation in this sense is going to mean collecting your data, examining it, making sure you really understand it. You've got to upload it into S3 because S3 is going to be the source for training all of your data. It's also going to be the place where we create a feature store. So the fundamental base of the forecast process, just like with SageMaker, is S3. So getting familiar with S3, creating a custom bucket just for this process is going to be important. You're going to need a custom IAM role. There are certain policies that need to be turned on in order to use forecast. That is made easy through the graphic user interface. You can, just as you can in SageMaker, you can easily create a forecast role. But in production, you may need to tweak that role a little bit because when you're just starting these journeys, you'll see that the automated role production that we have in the graphic user interface tends to be very permissive. So in the early days, you'll use that, the role that you get from the graphic user interface, but then you'll very quickly, when that goes into production, you'll narrow that down to just the very specific needs of the app that you're building. Next, you're going to create a dataset group that contains multiple data sets. And the way that we have worked this into the data ingestion process is we're modeling this data after a couple of key domains. And they are retail, inventory for supply demand, EC2, workforce prediction, web traffic, and metrics. And then we also have a custom column, which I'll expose in a moment. So the reason we do this is each of those different domains may have different requirements. They're all going to require one of these data set types. So the principal data set type is the time series data, the fundamental target time series data that you're interested in itself. But you may want to introduce a related time series. So in the example I gave before of the sneaker company, there may be various brands of sneakers. You may want to introduce the boots, as I've mentioned. So these are related time series data. You have different products with different time series data associated with it. Last but not least, there may be metadata associated with that. So as you're creating your data set group, when you choose that domain, you'll see what the options are for including this related time series and metadata. Now, when you choose the custom option, we make no real assumptions about what we need. In every case, you're gonna be required to use that time series, but we're not gonna assume that you're gonna have related data or time series data. Then you train your predictor. So the term here, the key concept is of a predictor itself. You'll train the predictor, you'll deploy the predictor. Once that predictor is deployed, you can then use that to generate forecasts. So I mentioned earlier that there are 8 algorithms that are involved with the forecast process. Here they are, and I just want to spend just 2 minutes on what these algorithms are and how you might be able to best use them. First of all, they are worth exploring each individually within forecast, and we have some pretty good documentation that will tell you, which one might be best for your use case. First is ARIMA, which I mentioned earlier, and that is used to fit a single model to individual time series, and then use that model to extrapolate where those data points might be in the future. It's a very popular algorithm available on scikit-learn, R, and other platforms. So it's sort of the superstar before deep learning began to take its place. And that's where deep AR comes in. Deep AR and Deep AR Plus, which is an optimized version of Deep AR, which is included in Forecast, is a supervised learning algorithm for forecasting one-dimensional time series using recurrent neural networks, or RNNs. In many applications, you may have a similar time series across a set of cross-sectional units. These time series groupings might be different products, server loads, requests, etc. So in this case, it can be beneficial to train a single model jointly over all of those time series, and Deep AR takes this approach. When your data set contains hundreds of feature time series, the Deep AR Plus recipe, which is what we call our algorithms, outperforms the standard ARIMA and ETS models. So you can also use the trained model for generating forecasts on new time series that are similar to the ones that have been trained on, and that's especially important for, say, new product introductions. ETS, which stands for exponential smoothing, fits a single model to each of an individual time series and then uses that to extrapolate. Using the exponential window function to assign exponentially decreasing weights over time instead of constant weights is applied in a simple moving average technique, has a lot of advantages in smoothing the input time series data set. You can apply this to data sets with seasonality or some other prior assumptions in the data. MDN is a mixture data network. That is a probabilistic deep neural network algorithm. It uses multiple time series and categorical attributes associated with a particular item to forecast a target variable. The MDN algorithm generates output as a mixture of Gaussians for all points in the forecast horizon at once. MQRNN is unique to Amazon. That's an algorithm that we've developed in-house that we use for demand forecasting with other one-dimensional time series data sets. NPTS, which is non-parametric time series, is a scalable probabilistic baseline forecaster. It predicts the future value distribution of a given time series by sampling from past observations. The predictions are bounded by observed values. NPTS is especially useful when the time series is intermittent or sparse or bursty. Prophet is Facebook's famous time series predictor. It implements a procedure for forecasting time series based on an additive model where nonlinear trends are fit with yearly, weekly, or daily seasonality plus holidays. It works best with time series that have strong seasonal effects and several seasons of historical data. Prophet is robust with missing data and shifts in trend and typically handles outliers well. SQF is an RNN based supervised learning algorithm for probabilistic forecasting for one-dimensional time series. The underlying RNN architecture is similar to Deep AR, except that it doesn't use likelihood. Instead, SQF estimates the quantile function directly and uses the continuous rank probability score as a loss function. So SQF is suitable for time series that do not follow standard parametric likelihood assumptions, for example, data with heavy tails. We also provide the random forest quantile regressor and a multi-layer perceptron model. So those are the algorithms. Obviously, it's worthwhile to do a little bit of research on those to see if you can manually optimize your model once you get used to forecast, and over time you want to see if you can improve this, sort of outthink the auto ML that's built in. And we may be adding more algorithms in the future. Like every other managed service at AWS, we do what we can to stay at the state of the art. Now, the outcome of your forecast are going to be predictions. And our predictor metrics are given here. They're principally root mean square error. When we load up your data set, we're going to use our validation set for optimization. And RMSE is going to be used to determine which is the best model. But then as you're projecting forward, we're principally looking at these prediction quantiles that are well described in our documentation, but they're also standard in statistical analysis, and they are P10, P50, and P90. So what do they mean? P10, what that represents is that the true value, in other words, the target prediction, is expected to be lower than the predicted 10% value of that time. So the P10 metric calculates the error of this prediction in relation to the actual value in the test data set. On the other end of that spectrum, we have P90, and that is where the true value is expected to be lower than the predicted 90% value of the time. In the center, we have P50, which reduces to MAPE, or the mean average absolute percentage error. So for P50, the true value is expected to be lower than the predicted 50% value of the time. And in most cases, the point forecasts that you generate with Forecast or with other forecasting tools should match the P50 forecasts. The P50 QL metric calculates the error of this prediction in relation to the actual value in the test data set. All right, so let's take a look. So I'm going to bring up a quick demo. Here we go. Hang on a second. Where are you? Got to hunt for this a little bit. There we go. That's not. There we go. Here we go. All right. So I'm going to start from the very beginning here. So when you go into Forecast, well, the way you find Forecast, first of all, is log into the console and just search for Forecast. And you'll find it. It's in the machine learning group of the AWS console. And the very first thing, as I mentioned, you're going to need to do is create a data set group. So when you click on that, you give it a name. We'll just give it today's date, 19. And it's the 18th somewhere in the world. It's actually the 19th where I'm sitting, but c'est la vie. And you have to be careful about the characters that you use, and I'll use an underbar rather than a dash, and I'll call this one for Melbourne. Then you need to pick your domain. As I mentioned, here are the domains. And we have EC2 capacity, custom, metrics, workforce, as mentioned before. I'm just going to choose custom in this particular instance. Now, I already have an IAM role, but if this is the first time you're using it, when you click on that, you'll see we have a convenience function here to create a new role for you. So you just click on create new role, and you get that role. Next up, you have to name your data set. I downloaded the UCI electrical data set from 2014. So I'll just put here UCI Electric 2014. The University of California in Irvine is a very popular repository for data sets. I'll also have a few links at the end of this presentation. Over time, I collect public data sets, and I make them available through a very convenient bit.ly leak. Those data, and we know this just because UCI documents their information very well, that the time interval in that data set is in hours, not days. So we set that to hours. It takes this timestamp. And our data set does not have headers. So as I was mentioning earlier, we need to know exactly how this data is going to come. Well, I'll tell you what, let's just look at it. Let's just open this up. You always have to look at your data. That is a key aspect of any process. Just going to take us a moment. I pulled out a head of this data. So here's the data, right? Let me blow this up a little so it's easier for everyone to see. And here we see the data, right? So we have our day, our hour, our value in float. And then what we're seeing here is in this data set, we're actually tracking the electrical usage for, I think it's a little bit more than 300 electrical utility customers. So at the end of this prediction, we should be able to take this particular customer, whoever client 0 is, In 2014, they were already using de-identified data. I'm very proud of them. And we'll be able to predict forward from this hour, from the last hour, on what their electrical requirements are going to be. So that's the data that we're using to model. And as we can see from this data, we have the timestamp, the value, and then the item, to use the language of forecast. But that's not the default that came up in our GUI here. Let's get that out of the way. What I see here is that the items last, the timestamps in the middle, and the value is at the end. So we need to rejigger this around a little bit, no big deal. Just change the JSON so that it reflects our incoming data set. Now, I have uploaded this to an S3 bucket, but I'm actually not going to fill this out just because I pre-baked this before the seminar webinar. But obviously, in here, you'd put your bucket name. And just get that out of the way, your bucket name, and then whatever key that you needed to get to that data. All right, so then you click on Create Dataset Group. So I have a little bit of this pre-baked, of course, to make life a little bit easier for us. So let's take a look. So I have here's a data set that I preloaded. It's the data set that I just showed. Once you create that data set, you can, it will then give you a status here that says that it's processing that data. And what it's doing here is that important step that I mentioned in the process where it's analyzing the data, doing some automated feature engineering for you. Then you need to train the predictor, and that's as simple as clicking this button that says train predictor. But let's take a look first. If I view this predictor, we'll see that we already have one that's in production. Let's click on the recipes here. So this is where you get a chance to actually choose the recipe that you're going to use. You can use what we call AutoML, not an expression I'm fond of, but we do use it, and it will automatically choose one of these algorithms for you based on the feature engineering and analysis that we did, or you can choose it yourself. And so they're all simply listed right here. Now, forecast lookup is sort of the icing on top of the cake. So if you want to find and do prediction on any particular item that you have put in, and as you recall from looking at our data set, we can say, client 0 here, choose a predictor type. Well, I only have one there. There's only one predictor version. We'll give it a start date of, 2014-01-01. And we'll just say that we're gonna just do 3 days of prediction and move forward, and then we'll predict by the hour, and then we click Get Forecast. So that's the GUI, and I am gonna make you wait to see the exciting charts and graphs because I know everyone loves charts and graphs, and just show you that all of that functionality is also available programmatically. And it's very likely that when you put this in production, you're going to be doing it programmatically through something like Python. So what we see here is we have a couple of sample notebooks, and I'll have the links at the end of this demo. I'm just going to bring one up here, which is really kind of a stripped down, very basic notebook that does everything that you just saw in the GUI, we're going to do here in Python. Now, because we're not in production yet, forecast is not part of Boto 3, so you do have to run this quick AWS configure at the beginning of this notebook. There's another popular notebook for forecast out there with a store called Favorita. This particular line is missing from that notebook, so you might want to copy and paste both this line and the contents that this line requires in order to enhance AWS CLI. So everyone who's on the webinar here now has that heads up, and you're not going to waste time because you didn't do that. So that's good. You may need to install Boto 3 and Pandas. You might notice in the kernel that I'm using here, for this particular kernel, I just need a plain vanilla Python 3. I'm not using any framework, so I don't need MXNet, TensorFlow, or PyTorch. Just plain vanilla Python 3 is all I need for this kernel. So as we step through this, well, first of all, our preview is only available in 2 regions right now. It's only available in West Virginia and the current region that I have specified here, which is Oregon. And then we test it. We say, okay, are you live? Can we access the forecast API? And we do that by using this listing routine that says list recipes. So by now you're getting familiar with what those recipes are, and those are easily accessed. In every data engineering process, preparing your data is a critical step. Here we're using Pandas to read in the data from a CSV file, and we expose the head just to take a look at what's inside, and we just did that before with my my editor, so you can see it looks very, very similar. Then we're gonna upload that data into S3. Here, regrettably, we're 9 cells in, and all of a sudden we notice we have to update a variable. But on this particular cell, you have to specify what's your unique bucket name. So you have to create a bucket, and this is really important. The bucket that you create has to be in the exact same region where you're running forecast. Okay, so when you're running forecast, you can see in the upper right-hand corner that I'm running in North Virginia. I'll switch this to Oregon here because I just happen to know that that particular, I wonder why that came up, that particular data set, there we go. That particular data set is in an Oregon bucket, not in a North Virginia bucket. So be very, very conscious of that, okay? Your S3 bucket data source has to match where you're running forecast. So then we just expose our variable, what's our bucket name, and expose a few other things, including our, importantly, our IAM information. Then we create the data set. We just saw this in the GUI, right? So this should look familiar, and we order our schema to match the data set itself. In this particular schema, we only had one data set type, which is our time series. As I mentioned, you can have multiple related time series that are added to this data set and metadata itself. So here we're just exposing that we've properly loaded this data set. We'll scroll down a little bit, and then we'll create the data set group. This is equivalent to clicking that button as we did, and then we see that it was successfully created. All right, now we import that data to do its our feature engineering analysis, and then here we have a little while loop that as that analysis is being done, we can get some feedback that says, hey, we're still creating this analysis, and you'll see that this loops, it could potentially loop for a very long time if you have complicated data set or there's some other factor where it's computationally intensive, but at the end of that, you're gonna see something that says active. Next, and here's just describing that that was successful. Next, we go in and actually say, what recipe are we going to apply? So here we're not using AutoML. Here we're using the Amazon specific algorithm MQRNN. So here we're saying this is the algorithm we're going to use. Don't bother recommending one. We're prescribing in this case. So let's move forward. And we do move forward here, and then finally, here we go again. So here now we're actually creating our predictive model. So in this while loop, we're simply saying, okay, here we're creating. Like I said, this goes on for a while. And then finally, your predictive model is ready. Now, you've got a model, but just like in SageMaker, after you create a model, it will just be sitting there in S3. We will create a feature store, which is really nice. But you do need to deploy that predictor in order to use it. So here it's a single command, and we see that it was successfully launched. It takes a little time to do that, but it finally does get out there. And now here we're going to actually do a prediction, and we're going to get the data for client 12. Now, it comes out in your Jupyter Notebook as a little bit of a mess. I have a tool which I'm going to go to next where we can actually just take a look at some of these results and discuss them a little bit. So this is using the actual forecast tool itself. And we can see here that our prediction is beginning at January 1st. Just from knowing the data, we know that that prediction is January 1st, 2015. So our prediction on client 12, whomever that is, on our P50 forecast is given, and our P90. So depending on whether you want to take your range for, and obviously we're looking at the graph here, but you saw the tabular data within the notebook, so obviously both are accessible. So here we have a predictive range for someone who looks like a really spiky customer. So this might be an office, for example, where people show up, they work, and then they go home. The next data set might be, say, for residential, or maybe for a company or a factory that's more 24/7. But you can see that the periodicity that's shown in the target values that precede the January 1st horizon look fairly consistent going into the future on an hour-by-hour basis. Oops. And then finally, we take a look at client 12. Once again, there seems to be a very regular periodicity to this particular data, and we have our P50 and P90 forecast given. All right, so I hope that looked simple. It's really just a matter of uploading your data, getting your data prepared to be examined, to either AutoML or pick your own algorithm, to create that model, put that model in production. And what I have here provided is some of the sample code that we just used, that we just looked at in this webinar. So the forecast samples actually have 2 notebooks. Well, there's actually 3. One just kind of tells you how to set up. But one notebook, the one we just examined, that runs fairly quickly. I would say it takes about a half an hour to process that particular notebook. There's another notebook in there that uses AutoML, and it's really extensive, and it takes a few hours to run. So be careful or patient with that notebook. If you have any questions, just email me. Then we also have this Favorita forecast. Now, Favorita is a department store, I think it's in Portugal, that provided some data to Kaggle for a Kaggle competition. So for that reason, because you can compare it to the results from the Kaggle competition, and for many other reasons, it's a great data set to look at and really begin to understand the richness and nuance of what's possible with forecast. Last but not least, I have a bit.ly link there to my personal collection of public data sets. You absolutely need data to do machine learning. So having at your fingertips this link where you could quickly explore all the data sets that we host here at AWS, UC Irvine, and then dozens of other public data sets, everything from government sources to university, academia, and private data sources, is absolutely essential. All right. So Chaitanya, maybe you can help me out here because I wasn't looking out at all. Are there any unanswered questions? And just to open it up to everyone who joined us today, are there any questions you have that we can address?
There is one that I answered. There are 2 or 3 that are not unanswered.
Okay.
Start with the first one. Can we send live data to train our model, like logs of applications? That is the first one.
So was the question, and I'm sorry, I can't expand this, was can you send live data to train or live data to forecast?
Both.
For inference, in other words, or training?
Both.
Both, okay. So training is going to take place in essentially a batch, in a batch process. Now you can set up a CI/CD model where, let's say, every hour, or whatever is relevant every day, you can begin to retrain that model. So the answer is absolutely yes, but you can't just sort of take tick by tick updating and retrain a model instantaneously. Not with Amazon Forecast. I have seen methods where, for security purposes, things like this, people have models then they're using, field programmable gate arrays, and they're training right on the edge and doing things like this. But no, not with Amazon Forecast. Amazon Forecast will require that you take, a batch approach, Now you can set that up to be cyclical or CI/CD. So that's that. And then obviously for inference, yeah, the whole point of getting that trained model is to send a post to an HTTP endpoint and be able to get your predictive results on demand instantaneously. So I hope that I answered that.
Thank you, Kris. The next one is, at GA, will forecast support bring BYOA mode, bring your own algorithm mode?
So the short answer there is no, not at GA. In fact, I don't want to speak for the service team, but I don't see it on the roadmap quite yet.
We
So
actually have a lot of questions, Kris, so we will take the next
yeah,
one.
I have time.
Okay. How do we choose, why do we choose median instead of mode values of likelihood function for generating point forecast?
So this is well, this is a choice. As I mentioned in sort of the description, that P50 is MAPE. So that's just sort of an industry standard. You could, I suppose, call it just an editorial choice. And that's one of the advantages of using, managed service, is that you have some I'm trying to use a word other than opinionated, but prescriptive, let's say, guidance on what the best options are for doing predictor evaluation. So yeah, so I think that's what you get. Now, obviously, you can use SageMaker, you could use DeepAR, or bring any of those algorithms into SageMaker. But as a managed service, that's what we chose for a forecast. So it does turn out to be very popular. So hopefully that's that opinionated or prescriptive selection does turn out to be the most popular use case.
Thank you, Kris. How much data is typically required as an input to develop a reasonable forecast?
Sure, that's always the $100,000 question. Using the related data feature, especially with DeepAR, the answer to that question can be of the related time series, not the target time series, but the related time series, it can be very little, or even in some instances, zero. So I'll ask the questioner here to please refer to the documentation for DeepAR, which is in the SageMaker documentation. So just search for SageMaker DeepAR. We go through that pretty extensively in that documentation and describe how we can use that example. The example I always use is, a sneaker company that's all of a sudden going to start selling boots. So that's one of the beauties of deep learning, is that you can use those latent characteristics to make that prediction from even no pre-existing data. So please do look into that. It'd be a little bit harder to answer that in any more depth than RTFM. Sorry, but to read the docs on how specifically that's enabled with DeepAR.
Thank you. And I believe there is another question which was referring to the BYOA mode, how to use Amazon for Cost to deploy custom models. So I guess your answer is, sorry, go ahead.
Yeah, no. Hey, go ahead, Chaitanya. You got it.
Yeah, so I guess the answer is not at GA, and refer to the document, I guess.
Yeah, or just use SageMaker. I mean, hey, this is a managed service for people that don't want to go through the effort of learning the mechanics of deep learning. And frankly, this is the trend, right? I mean, we just keep creating better managed services, all that have their roots in fundamental aspects that can be exploited with SageMaker. But yeah, if you don't see what you like in those 8 algorithms, and I have to say, that's a pretty well curated set of algorithms, from ARIMA to Prophet to ETS. I mean, these are the standard statistical models that you'll see in almost any like Tableau conference or something like this. So yeah, if yours isn't there, then go to SageMaker. You're in the caboose of that train that I described at the very beginning of the presentation.
Thank you, Kris. And I believe that was an answer for second question that was peeping up. There is another question. Is this available via API or only via console? I guess both. And there is parity maintained between the two approaches. That's correct, right, Kris?
Absolutely. Yeah, so just like all of our managed services have a GUI component to sort of kickstart you and get you familiar with the concepts. But you're almost definitely going to be using something like Python, a Python SDK, but you can also use Bash. You can also use the Bash shell. And I'll just on my screen here, just do a real quick demonstration. Let's see if I can just make this a little bit bigger so everyone can see. Make it nice and big like that. But if you just, if you have Python loaded up, if you do a pip install AWS CLI, just like that, you can get access. Well, I'm actually using a Windows command shell, but a Bash shell as well. And I'll just use SageMaker as an example. If you type AWS SageMaker and help, you'll see that we have the entire API exposed either in Bash or command line. So this is the exact same API that's available through the SDK. So yeah, this is fully exposed through Bash, through Python SDK, and through the GUI. The GUI, you know, we use the GUI just because when you're getting started, the concepts are visual, it's sort of easy to get, but that's why we walk through both the GUI and the Python notebook just to see how that works.
Thank you. This one is a SageMaker question. Are there any plans for SageMaker to support Spot instances?
Not that I know of. I do encourage you to consider using SageMaker local. Most of the time and expense that you're going to use in SageMaker is going to be, you know, obviously in the notebook. I tend to just use my IDE. I mean, you already saw it here. I tend to use, just because I'm on airplanes a lot and I just don't have a connection, I tend to use SageMaker local on my laptop with just Visual Studio Code. Spot instances are obviously not going to be great for persistent endpoints, and you're going to lose a lot of capability for auto scaling. But for batch transformation, I think it could be really handy. I could see, like, if you have a predefined model that's in a Docker container ready for inference, and you're using batch transformation, a Spot instance would be really, really nice to use. Although, you know, you could do that manually without SageMaker as well if you've already got the Docker container. So, you know, you're not really limited. Let me back up because I might be assuming one thing here. SageMaker itself, and we're sort of leaving forecast now for a moment, SageMaker is really built on this foundation of S3 and Docker containers. Within SageMaker, in the SageMaker examples, which is available through SageMaker Notebook, but also if you just go to GitHub, I might as well do it again. If you just say SageMaker example, just search for SageMaker examples. Oops, can't type when I talk. There we go. If you just search for that, you'll see that all the SageMaker examples are up on GitHub. It's open source. You can do a pull request, and I believe it's in advanced functionality. We have something called Scikit Bring Your Own Model. Here it is. And in this notebook, we walk through all the mechanics and even include all the bash commands that tell you exactly how to create that Docker container. So once you've done that, you can certainly use Spot instances. There's no reason not to.
Thank you. Sue, I want to do a quick time check before I move on to, like, there are a couple more questions.
Yeah, we're totally fine, Chaitanya. We've got just a few more minutes.
Oh, thank you. I'll leave a minute or two for Kris for his closing thoughts. Let's take one last question. How to use Amazon Forecast for cold start problem?
Sure. So the cold start problem would be in regard to using related data and metadata in your data set. So obviously that's going to be a lot easier if you're using one of the preset domains, and that's why we have that set up for you. It's not a requirement though, so if you don't have a retail use case or EC2 or web usage use case, you can select the custom model and simply include the metadata that you think is relevant. So if you were, once again, if you were, sort of had all these different sneakers and you had a multi-dimensional time series forecast, you're adding one more piece of metadata, that boot. You add the metadata for that boot to the model, and then you can begin to do some prediction on that. Now, obviously, cold start is difficult, and your probabilistic outcomes are going to be a little bit more speculative, and then as soon as you have some data, that model is going to get better. But the mere capability, the capacity to do cold start is really what deep learning has brought. That's kind of exciting, that folks are really starting to use, and yeah, it's a wonderful experience to do some predictions on introducing a related product to your existing product line, and to get some forecasts that are usable, that are worth sort of betting your money on.
Thank you, Kris. I believe we covered almost all of them. Any closing thoughts?
Sure. Just a few more things. It's great to have this webinar series. I love doing it. I think it's great for our team. And we do this every 2 weeks, so please do stay in touch. And I'm especially grateful to everyone who shows up to ask questions on the webinar. It means a lot to me. At this point, I've had a chance to meet many thousands of our partners, and it's so enriching for me. I love it. So I just want to thank everyone, certainly everyone who stayed through the whole call. But we also have some other resources here. We have the Machine Learning Solutions Lab and the Machine Learning University. So these are excellent starting points for getting practical education and hands-on expertise. Last but not least, please do follow me on some of my social media. I do run the New York City Deep Learning Meetup, and we're starting to create a pretty good YouTube library there. That's worth subscribing to. And I do try to post regularly, not only about my activities, but also discoveries that I'm making in the marketplace as I talk to AWS partners. So thank you very much for your time, and I hope to see you in 2 weeks again when we do our next installment of this series.
Thanks, Kris. Thanks, Chaitanya. Thanks to everybody who stuck around and asked great questions. In just a few minutes, when I close this webinar, you'll get 3 quick survey questions. If you could take a minute and answer those questions, we would so appreciate it. And then in about 6 hours, you will get an email with a link to the recording. So if you wanted to go back and just kind of have another look at some of what Kris presented, just give it a few hours and look for that email. And that's it for today. Thanks so much, and hope everybody has a great rest of your day.